Hello, my name is Kyle, and I am a mathematics student as well as a physics student at the collegiate level. And I enjoy math, physics, chemistry, tidbits of history, politics, economics. But for the focus of my video series, which I decided to start because when I get stumped on a problem, this is the first place I come to see if there's an example of a similar problem or a similar idea and see if I can translate that to what I am doing. So I figured I could start slow and work my way through and help those who are starting out. My first video is going to be that of the definition of the derivative, or a rate of change of some function, which is very helpful in Newtonian mechanics when you start discussing kinematics in physics. I will not bore you with the derivation of this function or functionality, this rate of change, this definition. If you want the derivation, if you don't have it, I'll be more than willing to write it up, put it in video form if you want, or just send it to you. Just send me an email and let me know. But I'm just going to do an example, and I'll do a couple more examples in later videos of more strenuous problems. But take a few seconds if you haven't. This is the functionality we'll be using for the definition of the derivative. And write it down because I will erase it to start the problem. Okay. I'm going to do a derivative of a simple polynomial at first. It's 6x squared minus 2x plus 4. Of course, that's f of x equals. And what we're trying to find, of course, is f prime of x, or the derivative. And what we know is the limit. I'm sure you've all been introduced to the limit of h, which is a small increment of x. It goes to 0 of this and what we're doing here is we are doing the function along with the tacking on the change of x. So we're tacking on h. So we have x plus h, and we set it up in the variable form. Everywhere you see this x, right, or y, or s, or whatever the variable is, you put this x plus h there. If it's raised to some power, you put that power there as well. Except now we're going to have to FOIL that out to get a correct answer. Minus 2 x plus h, of course. There is no power, or it's 1, but we don't use that. Plus 4, plus this little constant. It's there. It'll factor, it'll, motion its way out in the end, but for now we have to use it. Minus, and use your parentheses here so you don't mess up this sign or any other sign. Your function, 6x squared minus 2x plus 4. Alright, now all of this is over h, this small change in x, and if you think about it, all this is you're finding a slope, a rise over run. So it makes sense that, this is a delta y and that's a delta x. But now what we can do is we can FOIL this. And then we'll distribute this through, and then distribute the negatives through there. So we rewrite the limit, and always rewrite the limit. Always rewrite this limit until you go to evaluate it. Then it becomes numerical, and then you get an answer of 6 times. And when you FOIL this, you'll get x squared plus 2 x times h plus h squared minus 2x minus 2h. We distributed that through. Plus 4 minus 6x squared plus 2x minus 4. We just distributed that negative 1 through that part of the numerator. And again, this is all over h. So now we can distribute this 6. And remember, always write your limit. You'll get 6x squared plus 12 x times h plus 6h squared minus 2x minus 2h. That's a plus 4, of course. Plus 4 minus 6x squared plus 2x minus 4. And again, this is still all over h. But now what we can do is we can combine like terms and cancel off what will sum up to 0. 6x squared minus 6x squared, that'll go to 0. 4, positive 4 minus 4, that goes to 0. Positive 2x and a negative 2x, that'll go to 0. So what you're left with, which I hope you have this all written down, because I'm going to erase this top part. And write what you're left with up at the top here. The limit, as h goes to 0, of course, we still got our limit of 12x times h plus 6h squared, because that didn't cancel off, minus 2h all over h. And what we can notice about here, if you're doing these problems right, a delta x or an h will always fall out in the end, and it'll cancel in the numerator and the denominator. So what we get is, we can say therefore, the limit as h goes to 0 equals to, you pull this h out, plus, that's still 6h, minus 2 over h. And what we see here is, with law of multiplication, or multiplicative laws, we can cancel that out. Anything over h over h equals 1, c over c equals 1, 6 over 6 equals 1. So we see, all we have left, and I'm going to erase this part, I hope you have it, is the limit. And remember, the reason we couldn't just evaluate the limit at the beginning, and this is the part that a lot of teachers and professors don't talk about, is it's going to be something over, practically, something over 0. And that makes no sense. So, now we're getting to the point where h still approaches 0, and what you have is you have 12. I believe this is x, actually. Yes, that's x. 12x plus 6h minus 2. And then you plug that h in and see what you get. As you plug this h in, that'll go to 0, because 6 times 0 is 0. So what you get, Consequently, is 12x minus 2. And that's correct. And there's a sort of rule that you'll learn later if you haven't already called the product rule. Not the product rule, you'll learn that later. But that's not what we're going to use here. And I'll do some videos on the product rule later, and the quotient rule and the chain rule. But there's a little rule called the power rule that you can do. That basically states that, if you have some function f of x equals a, where a is a constant, times x, where x is a variable, raised to some power n, some numerical power n. The derivative of that equals a times n, so your constant times whatever this power is, times your variable x, which is raised to the power n minus 1. Basically what you're doing is you're taking your power and you're multiplying it by your constant in front of your variable, whether it's 1 or 100. And then what you're doing is you're taking this numerical power and you're just subtracting it by 1, whatever it is. If it's 1/2, it becomes negative 1/2. If it's 3, it becomes 2. So we can look and we can check ourselves, right? And if it doesn't have a variable behind it, like 4, there's no x there. That variable, consequently, when you do this power rule, will become 0, and any constant times 0 is 0 itself. So what we look at is, as we take this derivative up here and we're checking ourselves, and you can check yourself on an exam, but if it asks for going through the definition, you have to go through this process. But it's always good to check. And it's a fast way to get something done in the real world. If you're an engineer or a physicist or chemist or whatever you are. Well, 4, like I said, it's a constant that it doesn't have a variable. That variable will go to 0, so 4 times 0 is 0. We'll put that up there just for a placeholder for now, but you don't have to write anything that's 0 because, well, it doesn't sway the function one way or another. We look at negative 2x. Well, negative 2 times 1, because that's what this power is 1, is negative 2. And then x, it's 0 minus, this power is 1 minus 1, and that becomes 0. Anything raised to the 0 power becomes 1. So, negative 2 times 1 is negative 2. So let's do this one. 6 times 2, because that's what that power is 2, is 12. Well, 2 minus 1 is power. 2 minus 1 is 1. Well, we could just say that's x. And then we can, say forget the 0 or add it to the 2, however you want to see it. And isn't that the same thing? And it is. And I'll be uploading more videos. And like I said, if you want the derivation, let me know. If you want the derivation to just about anything, univariate calculus, let me know. A lot of multivariate calculus, differential equations, linear algebra, topology, anything you may be interested in, I can throw up here for you. But I will post more videos on physics and chemistry later, as well with more calculus. Just if you have any questions about specific examples, let me know, and I'll be happy to work them for you. And I'll even send them to you personally in your email or whatever. Alright, thank you.